think we've actually talked about it. Here's an example, reduce. And they'll give you something that looks like this, 2 times 3 times 2 times 2 times 3 5 over 2 times 2 times 3. Write that little problem. Now there's a hard way to do this and an easy way to do it. Neither one of them is right or wrong. One's just a lot easier and going to keep you from getting a lot wrong. You could multiply all this out. For example, 2 times 2 is 4. 4 times 3 is 12 times 5 is
60.
and then multiply all this out. 2 times 2 is 4 times 3 is and then actually do this division problem. 12 goes into 65 times and get your answer. Or you could do what we talked about today, and that is, well, maybe I should have done this a different way. Let me go back to 60 over 12. Okay, this is a fraction can be reduced, correct? What number goes into 60 and 12? Peter? Okay, I could divide both of these by half, and then I end up with 30 over 6. What number goes into both of those, PJ? 6. Divide that by 6 and divide that by 6, and I end up with 5 over 1, which gives me the same 5 I got over here. Now, if you're thinking about this just a little bit, you might think that you're kind of going around in circles. And the fact that here, I multiplied by a bunch of stuff only to divide by that same thing again. And division's the opposite of multiplication, so really, you went around the block a bunch of times to get to the same answer that you didn't have to go around the block to do. Which confuses all of you because it doesn't make any sense to me and I just said it. Okay? What you can do, children, to save yourself all of this time and effort here is reduce before you multiply. In other words, because here I divided by 2 2's and I ended up with the same fraction, you are allowed to, when you see it in this form, you can write this down. You can cross off like top and bottom numbers 1 for 1. And I'll show you what that means because it may not make a lot of sense to you, but it will here when we're done. Okay? What that means is this. If I see a 2 on the top and a 2 on the bottom, I can just say, oh, I'm going to divide both of those by 2 and they're going to go away. Here's another 2 on top with another 2 on bottom that crosses off. Here's a 3 on top that has also a 3 on the bottom. Okay, this 5 doesn't cross off because there's no 5's on the bottom. Okay, and look what I'm left with. 5 over, if everything crosses off, it's a 1. I'm left with 5 over 1, which is the same as the 5 I got here, which is the same as that 5 got there. Or you could think about it like this. Let me rewrite the problem like this. Think of this, see if this makes any sense to you. If you look at this just like this, what is 2 over 2?
1.
This is the same as 1. So I'm going to take a big red fat 1 and put it there. What is this 2 over 2 the same as? 1. What is this 3 over 3 the same as? 1. And what would be 1 times 1 times 1 times 5? 5. Okay? So rather than going through the long process of multiplying everything only to, in the end, divide it all over again, anytime you see something that looks like this, let me give you another example. 2 times 2 times 2 times 5. Over 2 times 2 times 3 times 5. If you see the same thing on top as the same thing on bottom, you can cross them off 1 for 1 though. I don't take this 1, 2 and cross off all the 2's on the bottom. It has to be 1, 2 with 1, 2, 1, 2 on top with 1, 2 on the bottom. So this 2 can cross off with this 2. This second 2 can cross off with the second 2. This 5, since it has the same 5 on the bottom, can cross off. These 2's and those 3's don't cross off, so that's what's left, and you're left with 2/3 as the fraction left over. Rather than multiplying all that, and then dividing it out and reducing it, you can do that. Now, a couple things to remember. If I would have been left with another 2 on the bottom, let's say there was a 2 and a 3 that didn't cross off, you have to re-multiply them and it would be 2/6. Okay, well actually there's 2 that crossed off with that. But if I would have had 2 numbers that don't cross off, you have to re-multiply. Hopefully they give us an example of that. Let me look and see if there's another one here. Yeah, I don't think they give me one like that, but I'll do another one. Well, let's say you have this. 2 times 2 times 3 times 5 times 7 over 2 times 3 times 5 times 11. They won't give you one like this, but hey, I can do whatever I want. What's going to cross off? Well, a 2 and a 2 cross off. A 3 and a 3 cross off. A 5 and a 5 cross off. Nothing else crosses off. So I'm left with you remultiply these, 14 over an 11, which we can't leave, but since I just made this up in my head, that's what happened. 14 11s, which is the same as what, 1 and 3 11s? You okay with that?
Sure.
Wonderful. Now, back to a new piece of note paper, which should be